All right, as we get ready to close up Unit 5, we're going to do a final review for our test. So let's look at this. All right. All right, let's look at number 1. The Bundles and Boxes Shipping Company sells small boxes for 75 cents and large boxes for $1.25. Carter bought a total of 108 boxes for $121. What is the system of equation? Remember, system of equations means two equations that can be used to find the number of small boxes S and large boxes L that he bought. Well, I know small needs to be a 75 cents. So 75 cents for small. B doesn't make sense because that's saying $1.25 for small. C doesn't make sense because that's saying $1.25 for small. Or D, 75 cents for small. Then it's saying large is $1.25. Large is $1.25. Large is, oh, well, it can't be that one because that says $1.24. Meaning that my answer has to be choice A. The small boxes plus the large boxes is going to give us a total of 108 boxes. And then 75 cents for small boxes plus $1.25 for large boxes equals the total amount of money of $121. Good. Alrighty, let's look at number 2. The family reunion consisted of 38 people who spent a total of $155 at a skating rink. Assuming that every family member skated, what is a system of equations that can be used to determine the number of adults and the number of children who attended? All right. Well, adults are 425 and children are 375. Usually I would use A and C, but I'm thinking here they used X and Y because that's what I see written down, X's and Y's. So I know that the money is 425, 375, and 155. So I need an equation that's talking about how the price of adults, 425, plus the price of children's, 375, equals 155. So it could be A, it could be B. C doesn't make sense because C is saying that the 425 adults equals the price of 155 minus the children. That doesn't make sense. And D doesn't make sense because we wouldn't equal it to 38 because 38 is just the amount of people. We need to keep money together. So between answer A and answer B. Let's look at the first equation. The first equation is saying X, the adults plus the children equals 38 people. Or B is saying Y being the children's equals the adults minus 38. Not that. So it's not going to be that one. So it will be answer choice A. All right, perfect. Let's look at 3. If f of x equals 1/2 x squared minus parentheses 1/4 x plus 3, close parentheses, what is the value of f of 8? This is telling us that x equals 8. So I'm going to rewrite my expression that I was given, and anywhere I see x, I'm going to put in 8. All right, let's try this. So 1/2 parentheses 8 squared minus 1/4 and then parentheses 8 plus 3 parentheses. And we get 27, which is answer choice C. Perfect. All right, let's look at 4. Lynn, Jude, and Annie were given the function f of x equals negative 2x squared plus 32. And they were asked to find f of 3, meaning x equals 3. Lynn said the answer was 14, Jude said the answer was 4, and Annie said the answer was positive 4 or negative 4. I'm thinking that only one person could be correct because I don't really know how I would type in a number for x and get 2 answers out. So let's see who is correct. I'm going to type in negative 2. I'm going to replace my x with 3, and I'm going to square it, plus 32. And when I do that, I get 14. Who said 14? 14 was Lynn. So my answer is choice D. Nice. All right, let's look at 5. Which of the following expressions represents a function? Well, in order for a table to be a function, none of the x's could repeat. But here x's do repeat, so my answer is not 1. So let me get rid of any answer choice that has 1 in it. Okay. Number 2. In order for an ordered pair to be a function, none of the x's can repeat. 1, 2, 3, 4, 5, 6, 7. So 2 works. So I need an answer choice that has 2 in it. Can't be A and can't be D, so my answer has to be B. Let's just look at the other ones just so we can go over it. 3 is not a function because if you drew a vertical line right here, it would cross twice, making it not a function. And this one is a function because if you drew that, it would be a straight line like this. And if you drew vertical lines through it, it would work, so that is a function. Alrighty, let's look at question 6. 4 relations are shown below. State which relations are function. Let's look at choice 1. So far it's a function. Ooh, right here it looks like it could be a function because remember we don't count open circles, so it only crosses through once. But then if I go like this, it's crossing through twice. So that would not be a function. So 1 is not a function because at x equals, what number is this? This is 1, 2, 3, 4, 5, 6. At x equals 6, it crosses the graph touches the vertical line twice. Good. And now let's look at the second one. In order for ordered pairs to be a function, we need to make sure no x's repeat. Oh no, but right here these x's repeat. So 2 is not a function because x equals 2 repeats. Perfect. All right, let's look at if 3 is a function. 3 is a function because none of these are repeating. State which are functions, so 3. And then this last one, if you were to graph y equals x squared, it would look like this u, which does pass the vertical line test, so that is a function. So 3 and 4 are functions. All right. All right, number 7. Which of the following graphs represent a solution to the system of equations below? Let's write the first one down. 3y plus 2x is greater than or equal to 6. I need to put this in y equals form. Well, y inequality form. So I'm going to get rid of the 2x, so it would be 3y is greater than or equal to negative 2x plus 6. Then to get rid of the 3, I'm going to divide by 3. And I get y is greater than or equal to, I don't need to flip my sign since I didn't divide by a negative, plus 2. All right, so this is going to be a solid line that we're going to shade above. And we're going to start at 2. Up 2, up 2, up 2, up 2. So they're all starting up 2, and I need my line to go down since it's negative. A is going down. They're all 3 going down. All right, that's good. Let's make sure they're all going down 2 to the right 3. Down 2 to the right 3. Yes, that is true. Down 2 to the right 3. Yes. Down 2 to the right 3. Down 2 to the right 3. Yes. Okay. And I need to make sure we shade it above. A wouldn't work. B would be good because that's shading above. For C, they did not shade above because then they would have had to have that little part shaded, so it's not C. So we're in between B and D. All right, for the second one, let's look at the second thing. 2x minus y is less than or equal to 7. Subtract 2x, I would get negative y is less than or equal to negative 2x plus 7. Let's divide by negative 1. When we divide by negative 1, we flip our inequality symbol. So that means we would have a solid line since it's less equal to, and we would shade above. All right. B, this is my second line. I need to see, did they shade above? Here they did shade above. That's good. But here, they shaded below, making that one not good. So our answer would be choice B. All right. Let's look at this next one. Which of the following graphs represents the system of equations below? All right. Let's look at the first one. 2y plus 3x is less than or equal to 6. Minus 3x. We get 2y is less than or equal to negative 3x plus 6. Divide by 2. And we get y is less than or equal to negative 3 over 2x plus 3. That's a equal to line, so we would have solid. And it's less than, so we would shade below. All right, starting at 3. Oh, this one doesn't start at 3, so it can't be A. Let's see B. B does start at 3. C does start at 3. And D does start at 3, okay? And my slope is negative 3 over 2, which means I need to go down. Down 3 to the right 2, yep. Down 3 to the right 2, down 3 to the right 2, okay? And I need ones that shade below. B is shading below. C is not shading below, so that's not good. And D is shading below, so that's good. All right, so we're in between B and D. Now let's look at the first equation. 2x minus y is less than or equal to 6. Let's get rid of the 2x by minusing 2x. We would get negative y is less than or equal to negative 2x plus 6. Let's divide by negative 1. When we divide by a negative 1, we are going to have to flip our sign, which would mean that now we would be shading above. So let's see which one's shading above. B is not shaded above. Well, no, actually, we're looking at this line now. Yeah, this is still shading below, so no good. But here, this one is shaded above, so it would be answer choice D. Nice. All right, let's look at number 9. Determine if the point 0, 4 is a solution to the system of inequalities shown below. 0, 4. 0, 4 means don't go left or right, just go up 4. 1, 2, 3, 4. Well, I see that point is in the 1 shaded section, but it's not in the double shaded section where we would have our solution set. So we would say 0, 4 is not a solution to the system because it is not in the double shaded section. All right. Let's look at number 10. What is one point that lies in the solution set of the system of inequality shown below? All right, let's look at 3, 0. 3, 0 means just go to the right 3, and we don't go up or down. That's A. Let's look at B. Negative 3, 5. 1, 2, 3, up 5. 1, 2, 3, 4, 5. B. It's definitely not going to be B because that's not in any shaded section. Let's look at C. 7, 0. 1, 2, 3, 4, 5, 6, 7. That's C. And D is 0, 7, 0, and then up 7. 1, 2, 3, 4, 5, 6, 7. Well, it's not going to be that one because that's only in the 1 shaded section. And the answer would be C because that's the only one in the double shaded section. A is just on the line of one of the inequalities. All right. Let's look at number 11. What is the domain of the function shown below? Let's look at what number we start with. We start over here at negative 1, and we end over here at 6. And domain means x, so I'm going to get rid of anything that's y. And we go from negative 1 to 6. Perfect, because remember, domain means x, which means from the left to the right. There was no arrows here, so that's why we didn't have any infinities. All right, let's look at number 12. What is the range? Range means y, which is, I like to think about low to high. All right, let me get rid of any answer choices that say x. Now, I'm thinking about how low, which is negative infinity, since there's an arrow, to how high does my graph go? The highest my graph goes is 0, which both of these say 0. This one says we're less than 0. This one says we're more than 0. Well, if I'm going downwards, if I'm going down, then I would be less than 0 because I'm going to the negative part. So it would be answer choice A. All right, let's look at 13. 13 might take us a little bit of time to think about this one. All right, so 13 is saying we have this f of x and g of x. 4 statements are written below. Which one is true? All right, they want to know when x equals 4, do we get the same result? So let's type these in. I'm going to type the first one in, the f1, 2 over 3. I'm going to make the x4 minus 4. That equals negative 4 over 3. And now let's see the g1. 1 over 4. Let's make x4 plus 1. That equals 2. Are those equal? Definitely not. So I'm going to get rid of any answer choice that says 1. All right, let's look at 2. 2 is saying when x equals 12, these are equal. So let's try it. 2 over 3. Let me make my x12 minus 4. That gives me 4. And let's see, is that equal to my g? My g is 1 over 4. Let me make my x12 plus 1. That would be 4. Are those equal? They are. So 2 works. So let me get rid of any answer choice that doesn't say 2. All right, let's look at 3. 3 is saying these graph intersects at x being 12 and y being 4. That's not, well, let's see. Let's make our x12 in both of them. Oh, no, that is true. We already made our x12, and when we did that, we ended up getting 4. So, yes, that is true. So, it would be answer choice A. All right, let's look at number 14. The graphs of the function f and g are drawn. Which one of the following statements about these are true? The graphs intersect when x equals 3. If this is true, then we would get the same value when x equals 3. Let's see if this is true. All right, for the first one, when x equals 3, 3 minus 3 is 0. That would be the absolute value of 0. Plus 1, we would get 1 for f. And now for g, 2 times 3 plus 1, that would get me 7. Are these equal to each other? No, so it would not intersect there. Let's look at b. The solution when these are equal is 3. Meaning that they're both equal when it equals 3. Let's see that. We'll see that in a second. C is saying the graphs intersects when y is 1, and D is saying the solution to them is 1. All right, let's do this right now. Let's graph the both of these so then we could see which one is true. All right, let's graph the first one, the f1. The f1 was the absolute value of x minus 3 plus 1. All right, and now let's go graph the second one, the g1, 2x plus 1. All right, that's a graph of what they look like. Let's see at what point they are the same number. What point are they the same number? Looking to see at what point are they the same number. Why am I not finding it? Let me go look at the graph again. I want to see what this number is right here. What that point is. Sorry, it's kind of hard to see on this graph. Pretty sure it's 1, 3. Pretty sure it's 1, 1, 3. Let me go back to the table. 1. Oh, I was missing it the whole time. The point where they intersect is the point 1, 3. So the solution is 3 where they cross. It's not y equals 1, and the solution's not 1 because we didn't end up with 1. So it is answer choice B. All right. Question 15. Which system of equations has the same solution as the system below? All right. The easiest way to do this is to solve this system. So let's do this right now. In order to solve this, we can multiply the first one by 3, and we can multiply the second one by -2. 3 times 2x is 6x. 3 times 2y is 6y. And 3 times 16 is 48. Now let's look at the next one. -2 times 3x is -6x. -2 times -y is +2y. And -2 times 4 is -8. All right, 6x minus 6x, nothing. 6y plus 2y is 8y. And 48 minus 8 is 40. We are then going to divide by 8, and we get y equals 5. And now let's see what x is. Let's look at our first equation. 2x plus 2, my y is 5, equals 16. That gives me 2x plus 10 equals 16. Let's subtract the 10, and I'll get 2x equals 6. I'm going to divide by 2, and I get x equals 3. Perfect. Alrighty. So I know that the solution to this one is x equals 3 and y equals 5. So I'm going to see which equation does this work for. Let's look at A. A says 2. I'm going to make my x 3. Then plus 2. I'm going to make my y 5. And I'm seeing, does that equal 16? It does. Now let's look at the second equation. 6. I'm making my x 3 minus 2 and my y 5. Does that equal 4? It does not. So A is not my answer. We already tried the first equation for B, and we see that's correct. Now let's try the second one. 6, oh, it equals 8, which I did get, so B is the answer. So all you're going to do is you're going to solve the first one, the original problem, find out what your x and y is. You could then type into the calculator what x and y equals, and then you're going to see, do both of the equations become true or false? All right, let's look at number 16. Which one of the following pairs of equations could not be used to find the following equation, x and y? All right, so basically they're saying you're going to find an answer for x and y, and then you need to see which ones does not get you the same answer for x and y. So let's look at 16. I'm going to multiply the first equation by 2 and the second equation by 4, but I do not need to make any of them negative since I already have an x that's negative. 2 times 4x is 8x. 2 times 2y is 4y. And 2 times 22 is 44. 4 times negative 2x is negative 8x. 4 times 2y is 8y. And 4 times negative 8 is negative 32. All right, let's add these together. 8x minus 8x is 0. 4y plus 8y is 12y. And 44 minus 32 is 12. Divide by 12, y equals 1. And now we could use either equation to find what x equals. I'll just use the first one. 4x plus 2, replace my y with 1, equals 22. That would give me 4x, 2 times 1 is 2, equals 22. I'm going to subtract 2. I will get 4x equals 20. Divide by 4, x equals 5. Perfect. So now I'm going to try this. Let's try answer choice A. 8. X is 5 plus 4. My y is 1. Does it equal 44? Yes. Let's try the next one. Negative 8, make my x 5, plus 8, make my y 1. Does it equal negative 32? Oh, it doesn't. So look, I already found the one that doesn't work. That was nice. I didn't have to try all the answer choices. I already found one that doesn't work because I needed it to equal negative 8, but it equaled negative 32. All right, let's look at number 17. An expression of the fifth degree is written with a leading coefficient of 7. Fifth degree means our highest exponent is 5. So it can't be A, it can't be B, it could be C, and it could be D. Then it says a leading coefficient of 7. That means the number in front of the degree 5, the exponent 5, needs to be 7, which is answer choice C. And then it says constant of 6, which means the number alone without x has to be 6. All right, let's look at number 18. When multiplying polynomials for a math assignment, Pat found the product to be this. He then had to state the leading coefficient, and Pat wrote down negative 4, since he's seen negative 4 was the first number. Do I agree with Pat's answer? Well, the leading coefficient is the number in front of the highest exponent which here is the negative 2x3. So Pat should have said negative 2. The leading coefficient is negative 2. Since the highest exponent is 3, x to the third, and the number in front of the x to the third is negative 2. All right, let's look at 19. Frank is going to buy some socks, $7.50 per pair, and some shirts, $8.50 per shirt. If he buys twice as many pairs of socks as shirts, so his socks is equal to twice the shirts. It says if he buys twice as many socks as shirts and spends no more than $2.50. All right, let's make X socks and let's make Y shirts. So his socks, X, are equal to twice as many shirts. All right, so he's buying, the first thing he's doing is buying shirts. Then he's also buying the socks, which is 2Y. And he spends no more than $205, which means he has to spend less than or equal to $205. What is the greatest number of shirts he can buy? Well, y plus 2y is 3y is less than or equal to 205. Divide by 3. Y is less than or equal to 205 divided by 3 is 68.3. And y does represent shirts. So right now, the greatest amount of shirts that he could buy can't be 69 because that would be greater than 68.3, so it would be 68. So the greatest number of shirts he can buy is 68. Good. Oh, no, not good. I forgot a big part. Not good at all. I forgot a huge part of this. I made a humongous mistake. Please do not do what I do. So, first he bought socks. Socks were X, which socks cost $7.50. So I should have put $7.50X. Then the shirts were $18.50, which shirts were Y, which that had to be less than $205. And then I know that X is equal to 2Y, so I can replace this X with 2Y. Plus 18.50Y is less than or equal to 205. 750 times 2 is 15Y. Plus 1850Y is less than or equal to 205. Then 15 plus 1850 is 3350 y, which is less than or equal to 205. Then we do 205 divided by 33.5, and we get that y is less than or equal to 6.119 ... So the greatest number of shirts he can buy is 6. 6 shirts. Oh, I was about to forget a key part, which was those monies. Sorry about that. All right, let's look at 20. Ramos buys some pens and pencils. All right, so he's buying pens, which I'll make X, and he's buying pencils, which I'll make Y. He buys 7 more pens than pencils. 7 more pens than pencils. So his pens are equal to 7 more than pencils. So 7 plus pencils. All right. Pens cost 45 cents, which we know pens are 7 plus the Y. And pencils are 40 cents, which we know that pencils are Y. And he has $10 to spend, which means he could spend less than or equal to 10. So 0.45 times 7, that gets us 3.15, plus 45 times y is 0.45y, plus 0.40y is less than or equal to 10. So we'll have 3.15 plus 0.85y is less than or equal to 10. We are then going to subtract 3.15, and we will get 0.85y is less than or equal to 10 minus 3.15 is 6.85. I'm then going to divide by 0.85, and I get y is less than or equal to 8.0588 ... So the maximum number of each he can buy is, well, first let's talk about pencils. The maximum number of pencils he can buy is 8. 8 pencils. And we know that his pens are 7 more than the pencils, so 7 plus 8 would be 15 pens. Good. And let's just make sure this makes sense. 8 pencils. 8 pencils. Pencils cost 40 cents. Plus 15 pens. And pens cost 45 cents. And is that less than 10? It is less than 10. Good. All right, number 21. Jim and Guy work at furniture stores. Guy is paid $185 per week plus 3% of his total sales in dollars, which can be represented by this equation. Jim is paid $275 per week plus 2.5% of his total sales in dollars, which can be represented by this equation. Determine the value of X in dollars that will make their weekly pay the same. If I want their weekly pay to be the same, that means I want this to equal this. So I'm going to equal those together. 185 plus 0.03x is equal to 275 plus 0.025x. All right, I want to get my x on one side, so I'm going to bring this 0.25x to the other side. That will give me 185 plus 0.005x. Let me just make sure that's right. 0.03 minus 0.025. Good. Equals 275. I'm going to bring my constant over by subtracting this 185. That will give me 0.005x equals 275 minus 185. which is 90, divided by 0.005. And I will get x, which is 18,000. Good. Meaning that the value x in dollars that will make their weekly pay the same is 18,000. Good. All right, let's look at question 22. Type A is 3 feet tall and grows at a rate of 15 inches per year. So A is 3 feet tall, starting at 3 feet, and grows at a rate of 15 inches per year. So 15 per year. Good. B is 4 feet tall and grows, when you're growing, you're adding, at 10 inches per year. Determine how many years it will take for these trees to be the same. If I want these to be the same, I want them to equal each other. So I'm going to do 3 plus 15y equals 4 plus 10y. I'm going to subtract 10y from both sides, and I will get 3 plus 5y equals 4. To get rid of the 3, I'm going to subtract 3 from both sides. That will give me 5y equals 1. Divide by 5. Y equals 1 over 5. Which means that it would take a fifth of a year for them to be the same. Let's make sure this is true. 3 plus 15, and in a fifth of the year, it will grow to 6. So let's see this one. 4 plus 10, and a fifth of the year, it will be 6. So yes, determine how many years it would take 1/5 of a year. Good. All right, 23. If C equals G minus 3F, find a trinomial that represents when F is this and G is this. So I'm going to write C equals G. My G, I'm going to put it in parentheses, is 3x squared plus 4 minus 3F. F, I'm going to write down 2x squared plus 6x minus 5. All right, let's do this. Leave the 3x squared plus 4 alone. Then negative 3 times 2x squared is negative 6x squared. Negative 3 times 6x is negative 18x. And negative 3 times negative 5 is 15. Good. Now 3x squared minus 6x squared is negative 3x squared. Then let's bring down the negative 18x. And then 4 plus 15 is 19. And this would be what C equals. Great job. Let's look at 24. If A equals this and B equals this, then what is A minus B? All right, A is 3x squared plus 5x minus 6 minus my B, which is negative 2x squared minus 6x plus 7. All right, so we're going to have 3x squared plus 5x minus 6. And let's distribute this negative. Negative times negative 2x squared is positive 2x squared. Negative times negative 6x is positive 6x. And negative times 7 is negative 7. All right, now we have 3x plus 2x squared, which is 5x squared. Then 5x plus 6x is 11x. And negative 6 minus 7 is negative 13. And this is our final answer, which is answer choice D. Good. All right, let's look at question 25. Solve the given system of equations graphically, of inequalities graphically. They didn't give me an x and a y, but I'll just make this my x and I'll make this my y. It's okay if it's not perfectly equal. All right, let's graph the first one down first. 6x minus y is greater than or equal to 5. I need to get the y to be the only thing on the left side, so I'm going to subtract 6x. That's going to give me negative y is greater than or equal to negative 6x plus 5. Then I'm going to divide by negative 1 if I divide by -1, I have to flip my inequality symbol, which is going to leave me with 6x minus 5. That means I'm going to start by going down 5. So I'm going to go down 5. 1, 2, 3, 4, 5. And my slope is 6 over 1, which means I go up 6 to the right 1. 1, 2, 3, 4, 5, 6 to the right 1. Let's see if I can do it one more time. 1, 2, 3, 4, 5, 6 to the right 1. Perfect. Now, this would be a solid line since it is an equal to line. So I say solid. And we shade below since I flipped my symbol and it became a less than symbol. Perfect. And this was the inequality 6x minus y is greater than or equal to 5. All right, let's look at the next inequality. 4x plus 3y is greater than -9. Subtract the 4x. That's going to give me 3y is greater than -4x minus 9. I'm going to divide by 3. This will leave me with y is greater than -4 over 3x. And -9 divided by 3 is -3. This will be a dotted line. And we shade above. All right, with the -3, that's going to mean I go down 3. 1, 2, 3, and I put a dot. Then with my -4 over 3, that means I go down 4. 1, 2, 3, 4, and I go to the right 3. 1, 2, 3. And let's go the opposite way. Up 4. 1, 2, 3, 4. To the left 3. 1, 2, 3. Up 4. 1, 2, 3, 4. To the left 3. 1, 2, 3. Perfect. Now I'm going to make this a dotted line. I'm going to put arrows. And I'm going to shade above. Perfect. And this is the inequality. 4x plus 3y is greater than -9. And the area where they are both shaded in together, that is my solution set. Good. Now let's look at this next question, number 26. On the axes provided, graph the solution set of this inequality. All right, let's do this. This could be my x right here, and this could be my y. Alrighty, let's look at the first one. 3 minus 3y is greater than or equal to 6x. So I'm going to minus my 3 from both sides. That will give me -3y is greater than or equal to 6x minus 3. I will divide all things by -3. And that will give me y. Because I'm dividing by -3, I have to flip my sign. 6 divided by -3 is -2x. And -3 divided by -3 is +1. All right, this is going to mean I'm going to go up 1 to start. Then my slope, I go down 2 to the right 1. 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 I could also go up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. This is going to be a solid line, and we're going to shade below. All right, solid since it's equal to. Put arrows, and we shade below. And this is the equation. 3 minus 3y is greater than or equal to 6x. And the next one, x is greater than or equal to -3. Well, x -3 means we go to the left 3, 1, 2, 3, and we put a point. And then we put a line right through it, a solid line. And because we are greater than, that means we are all the numbers greater than that. Which means our double shaded section is this little part right here. And this is the inequality. X is greater than or equal to -3. All right, let's look at number 27. Solve the given system of equations by an algebraic method that eliminates. So we're using the elimination method. Let's try this. So I'm going to multiply the first equation by 4 and the second equation by 3. Because neither of these are negative, I'm going to make the bottom one negative. 4 times 3r is 12r. 4 times negative 8 is negative 32s. And 4 times negative 19 is negative 76. Then negative 3 times 4r is negative 12r. Negative 3 times negative 5 is positive 15s. And negative 3 times negative 14 is 42. All right, now let's add these together. 12 minus 12 is 0. Negative 32 plus 15 is negative 17s. And negative 76 plus 42 is negative 34. I'm then going to divide by negative 17, and I get s equals 2. All right, now to find r, we can use either of the equations here. I'll just use the first one, 3r minus 8. I'm going to make my s2 equals negative 19. I would get 3r. Negative 8 times 2 is negative 16 equals negative 19. To get rid of the negative 16, I'm going to add 16 to both sides, and I will get 3r is equal to negative 3. Divide both sides by 3, and I will get r is equal to negative 1. Perfect. All right, let's look at number 28. All right, question 28 says, at an amusement park, the cost for adult admission is A, and children admission is C. For a group of 6 that includes 2 children. So there's 2 children, and if there's 6 people total, that means there would have to be 4 adults, and that cost is $325.94. Then it says, for a group of 5 that includes 3 children, if there's 5 people total with 3 children, that means there has to be 2 adults, and that cost was $256.95. All right, we just wrote our system of equations. Now we need to solve it. All right, we don't have much space to do this, but we're going to use the space that we do have. We're going to multiply the first one by 3 and the second one by negative 2. Let's do it. 3 times 2c is 6c. 3 times 4a is 12a. And 3 times $325.94 is $977.82. Good. Then negative 2 times 3c is negative 6c. Negative 2 times 2a is negative 4a. And negative 2 times $256.95 is negative $513.90. All right, let's add these together. 6 minus 6, 0. 12 minus 4 is 8a. And $977.82 minus $513.90. That gives us $463.92. I'm going to divide by 8, and this would give me A equals $57.99. All right, so that's the price of adults. Now we need to find the price of children. To do this, I will use the first equation. 2, I don't know the price of children, plus 4, adults are $57.99, equals the total price of $325.94. So I will have 2c plus 4 times $57.99 is $231.96, which equals the total amount. Now I'm going to subtract this. This will leave me with 2c equals 325.94 minus 231.96. That's $93.98. Divide by 2. C equals $46.99. All right, I finally got my 2 prices. That is all for question. That was all for question B. All right, now let's look at question C. Determine the cost for a group of four that includes 3 children. Well, 3 children would be 3 times the children price is $46.99. That would be $140.97. And then the one adult would be $57.99. So let's add those together. And I get that the total cost would be $198.96. And you can write that. For a group of 4 with 3 children, the total cost would be $198.96. All right, let's look at question 29. Deb and Luke go to an entertainment store to purchase CDs C and DVDs D. Deb buys 3 DVDs and 2 CDs for $63. At the same store, Luke pays $46. At the same prices, Luke pays $46 for 1 DVD and 4 CDs. Write and solve the system of equations to solve this. All right. So I can multiply the first equation by 1 and the second one by -3 since there's no negatives. So I'll keep the first one the same. 3D plus 2C equals 63. And then -3 times 1D is -3D. -3 times 4C is -12C. And -3 times 46 is -138. All right, let's add this together. 3 plus -3 is 0. 2C minus 12C is -10C. And 63 minus 138 is -75. Let's divide by -10. And that would give us that CDs are $7.50. All right, now to find how much DVDs are, let's go and look at this. Let's rewrite the first equation. 3D plus 2, I'm going to make CDs $7.50, which equals $63. So then 3D, 2 times 750 is 15, equals 63. Minus 15, we will get that the 3D DVDs is 63 minus 15 is 48. Divide by 3. We get DVDs are $16. And let's make sure this makes sense. Let's plug in 3 DVDs are $16 plus 2 CDs are $7.50. That does equal 63. Then 1 DVD, which is $16, plus 4 CDs, which are $7.50. Does it equal 46? It does. So we are good. CDs are $7.50 and DVDs are $16. All right, let's look at question 30. Mrs. Wilson bought 5 hot dogs and 3 sodas for $7.75. Mr. Ramey's goes to the same store and buys 2 hot dogs and 2 sodas for $3.50. Hot dogs are H and sodas are S, and we need to find them. All right. So we're going to multiply the first equation by 2 and the second one by -5 since there's no negatives. 2 times 5H is 10H. 2 times 3S is 6X. And 2 times 775 is 1550. Then -5 times 2H is -10H. -5 times 2S is -10S. And -5 times 350 is -1750. Okay. 10 minus 10 is 0. 6 minus 10 is -4S. And 15.5 minus 17.5 is -2.5. Divide by -4. We will get S equals Negative 2.5 divided by negative 4 is 0.625. I just want to make sure I didn't make a mistake anywhere. 2 times 5 is 10. 2 times 3 is 6. 2 times 7.75. Okay. Negative 5 times 2 is negative 10. Negative 5 times 2 is negative 10. And negative 5 times 3.50 is that. Okay. 6 minus 10 is negative 4. And 15.5 minus 17.5. Oh, this should just be 2. And 2 divided by negative 4. Negative 2 divided by negative 4 is just 50 cents. Okay. Good. So now let's find the price of sodas. Let's rewrite of hot dogs. Let's rewrite the first equation. 5h plus 3. The sodas are 50 cents equals 7.75. So we have 5h. 3 times 50 cents is $1.50 equals 7.75. Minus 1.50, we get 5h is equal to 7.75 minus 1.50 is 6.25. Let's divide that by 5, and we get hot dogs are $1.25. So hot dogs are $1.25, and soda is 50 cents, and that's what they wanted us to find. All right. That wraps up our review on everything we need to know for Unit 5 exam.